Hey everybody, we're going to do some of my favorite things, solving inequalities graphically. I know, doesn't it sound like amazing, tons of fun? So, the beauty about it being on video is you can stop, go backwards, pause, play it fast, play it slow. I'm going to talk pretty fast, but you can always pause it. So, here we go. Solve and graph the solution set on a real number line. So I've got 2x squared plus x is greater than 15. So I'm just going to take some time at first to notice some things. First of all, I see that I've got to find something greater than. So really it's just like solving equals to, but then afterwards we need to think a little bit more carefully. I also notice that it's an x squared. So that means it's a quadratic. So what are going to be my processes for doing that? Well, let's look over here. Step 1. It says get 0 on one side of f of x. Okay, really what that means is because it's an x squared, we get it equal to 0. So then I go in and I think, all right, what would get this thing equal to 0? I can draw my line down if I want to, if that sparks your brain. I'm going to get this 15 over there. Well, it's positive 15, so minus 15. But please remember, you can't actually take that away from anything. You just rewrite it in there. So I've got 2x squared plus 1x. You might say, I don't need the 1x. Okay, fine. X, whatever. Minus 15. Okay, it's still greater than 0. All right. So I got everything to one side. What does it tell me to do next? Find the zeros. All right. When it says find zeros, you should say to yourself, Yahoo! I'm going to factor. Okay, whenever you see an x squared, you should probably think, oh, I wonder if I can factor. Now, because the beginning is 2x squared, I know that I've got 1x and 2x. Those are my only two options. Okay, over here, I'm going to think you might already know the answer, but I'm going to pull apart 15. I could do 1 and 15 or 3 and 5. And ultimately, when I put them together, the middle, I know one's going to be positive, one's going to be negative because of that minus 15. When I put them together, they have to add up to 1x. So hopefully you've already got it. Maybe I'm going to go with the 3 and the 5. So pause if you can't figure out why. Just pause me until you figure it out. Okay, so I'm going to put the 3 here, the 5 here. I know that when I add the things together, they've got to give me plus 1x. Okay, so 2x times 3 gives me 6x. And 1x times 5 gives me 5x. One of them has to be positive, one has to be negative. They add together to give me positive 1. So then 5 has to be negative, the 3 has to be positive. Okay, so how do I actually write that? Then I come over here, first parentheses, second parentheses. Then first x, second x, first number, second number. Okay, now quick foil that in your head. Does that work? It does. Okay, but I'm a little bit out of room, so I'm going to move this over. Alright, so now I've got this, but originally, do you remember how originally it said, okay, so I've got x plus 3, 2x minus 5. Don't forget that we need to have that all greater than or equal to 0. So I'm going to look right here. X plus 3. What plus 3 gives you 0? That would be negative 3. And right here, what's going to give me 0 there? That's going to be, well, I take this sign and change it, positive 5. But then it's just not positive 5, it's positive 5 halves. Okay, those are my two zeros. So get the 0 on one side, check. Find the zeros, check. Alright, let's see what it says next. Plot the zeros on a number line and sketch the graph using the concepts of LCT, shape, and end behavior. Okay, this is my favorite part. Okay, so I'm going to plot my things on plot the zeros on a number line and sketch the graph. Okay. So basically, if I put a number line out, here we go, let's say right there. I'm just going to put, here's my 0. Okay, so that's not technically a number line, it's a whole thingy-dingy. Sorry, forgot the technical word. coordinate plane. So I'm going to go 1, 2, -3. Here's -3. I'm going to put my 0 there. Then I also have a 0 at 1, 2, 3. 5/2 is about 2.5. Okay. Now, if I look at the original, it says x squared. So what's the mother function of your x squared? Yeah, it's a parabola, and it's opening up. Do you know why it's opening up? Got it. It's opening up because it's positive. Okay, so here's what's going to happen at the end. There we go. Now, in the middle, it's going to come down and it's going to U up. But how specific do we need to be? Analyze the graph in comparison to that or that, and write the solution. Okay, so at this point in time, I'm just looking for when is it greater than 0. So I don't have to be super specific about what this looks like. So down here, U is down here. I don't care how low it goes. My goal is to figure out, my ultimate goal was to figure out, okay, when is it greater than 0? So here is 0, so greater than is this stuff up here. So it says analyze the graph in comparison to that. I want it to be greater than, so that's up here. And so then write the solution in interval notation. Okay, so I look, and when is it happening? It's happening to this side of 3 and to this side of 5/2. So how do I write that? Well, I start way over here. What's the number for way, way, way over there? -infinity. I go, go, go until I hit -3. Okay, does it include -3? Well, what does this say? It says greater than. So, does it include -3? No. So it's open, then a union. I skip for a while till I get to 5/2. Doesn't include 5/2 because it says greater than, not greater than or equal to positive infinity. All right, so there is one. Why don't you go down lower and try the next 3 on your own, and I'll make the next video that will help you with that if you need it.